Now this looks impossible, and it might seem impossible for some, but when you actually break it down, it's not really that hard. So here we have actually a hidden quadratic with exponentials. Now how do I know it's a hidden quadratic? It's because I've done this already, but I'm going to show you how I know how to do it. So the first thing you want to do is you want to rewrite anything that has powers. So look at what has powers in this. 2 to the power of x and 2 to the power of 2x. Now we cannot rewrite this any further, so we're going to leave it. What I'm going to do is I'm going to institute a substitution. So I'm going to let a equal 2 to the power of x. And this is important, so I'm going to write it up here. A is equal to 2 to the power of x. This is important because we're going to be subbing in a when we see 2 to the power of x. Okay? So let's do this. 3 times 2 to the power of 2x. Remember, 2 to the power of x is a. So this will actually be a squared. The reason why this is because 2 to the power of 2x, we can rewrite that as 2 to the power of x in brackets and then 2 on the outside using our index rules, where a to the power of m in brackets with n is just a to the power of m times n. So that's still the same, right? And since 2 to the power of x is a, we know that it's a brackets squared, which means this is a squared. So we know that's a squared. So let's continue. So we got up to 3 times a squared minus 18a, because remember 2 to the power of x we say is a. Then plus 24, because there's no power there, and that's all equal to 0. Now, let's just rewrite this in a simpler form. 3a squared minus 18 plus 20, my bad, plus 24 is equal to 0. Now what we do is we solve this like a regular quadratic. How am I going to do that? Because it seems hard, because it's non-monic. I realize that every one of these terms, every one of these numbers are divisible by 3. So I'm going to divide this whole side by 3. I'm going to divide this 0 by 3, which means it's just equal to 0. Now let's do this side, the left-hand side. 3a squared divided by 3, that's just a squared. Minus 18 divided by 3, that's just negative 6a. Then 24 divided by 3, that's just positive 8. That's really wonky, so I'm going to rewrite it. A squared minus 6a plus a is equal to 0. Now, think about our solving for quadratics. We can do factorizing, completing the square, and the quadratic formula. But I notice here, this is probably factorizable. So what I'm going to do is I'm going to set this up into double brackets. Because remember, any quadratic factorizes into double brackets, quadratic trinomials. So, and it's monic, so it's 1. So I look at the factors of c that add to give to b. So what are the factors of 8 that add to give to negative 6? Let's think about them. 1 and 8, 2 and 4. Now it seems like we don't have any more factors, but remember, a negative times a negative is also a positive. So negative 1, negative 8, and negative 2, negative 4 are also factors of 8. And as we can see, negative 4 plus minus 2, that gives us minus 6. So those are the two factors we're going to do. So I'm just going to put these numbers in here. A equals minus 2, a minus 2, a minus 4 is equal to 0. And then if we factorize that out, that's just a squared minus 4a minus 2a plus 8, as we know, a squared minus 4a minus 2a plus 8. And then we simplify that, and that would equal to minus 6a plus 8. And then a squared is just left there. So that is how I know it's correct. So we have factorized this correctly. Now all you do is use the null factor law to solve for a. So a minus 2 is equal to 0, or a minus 4 is equal to 0. Now the reason why this is because the null factor law, remember, if this whole thing's equal to 0, and these are being multiplied by each other, that means one of these terms have to equal to 0. So we just set this side equal to this whole side equal to 0, or this whole side equal to 0. So that's how we get that. So a plus 2 equals 0, just plus 2 on both sides. A is equal to 2. Or a minus 4 equals 0, or just plus 4 on both sides. A is equal to 4. Now we're not done yet. Remember, we set a substitution. A is equal to 2x. So let's put that down here. A is equal to 2 to the power of x. Now what we do is we know our a values. A is equal to positive 2 and positive 4. So let's sub this back in to here. So 2 is equal to 2 to the power of x, or 4 is equal to 2 to the power of x. Now you do is you want to rewrite when possible. So as we can see here, we cannot rewrite this. So what is 2 to the power of 1? That would equal 2, because remember 2 to the power of 1 is just itself. And then all we do is the powers equate because the bases are the same. So x would be equal to 1. Or we can rewrite this 4 into 2 to the power of 2 equals 2 to the power of x. And then we just equate the powers because the powers are the same if the bases are the same. So that would be x is equal to 2. So our final solutions are x is equal to 1 or x is equal to 2. That is our answer. How good.